Good morning, dear students. Myself, Dr. Priya, working as Associate Professor in Chemistry, Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. In today's class, we are going to discuss about lithium-ion battery, which is an example for secondary battery. So, what is its construction and what is the working principle involved and the cell reactions, and then applications of lithium-ion battery. So, coming to the construction part, lithium-ion battery, as I told you, it is an example for secondary battery. That means both the forward as well as backward reactions will take place. That means during forward reaction, it is acting like an example for voltaic cell, and in the backward reaction, it is like working like an example for electrolysis process. So, let us see how it is possible. And why this lithium it is chosen for batteries construction means, so as I told you, it is rechargeable. That means both the forward and backward reactions take place, and it is the very lightest metal, very light in weight. When compared to other metals, it is having very light weight. That's why it is used in the batteries construction part. And this lithium is able to generate very high energy density, that is very high voltage whenever it is used as a source of electrical energy. And then it is very much flexible to get different output voltage values. Basing on the requirement, we will get different output voltage for lithium-ion battery. So, as it is having very high energy density as well as very high voltage, it is having applications in smartphones, or we will call them as mobile phones, laptops, digital cameras, and then even electric vehicles also. We were having lot of applications in lithium-ion battery. So, if you notice this picture is able to reveal us that it is an example for lithium-ion battery. Its output voltage, it is 3.7 volts. It is mentioned here, labeled here. So, this is the battery that we use in mobile or smartphones. Nowadays, we are using smartphones, in which if you notice the battery part, so it is of 3.7 volts. Its output voltage, it is 3.7 volts. That kind of a lithium-ion battery generally we will use. So, this is made by that LG brand, like Sony. Every brand will use this lithium-ion batteries of varying output voltage values. So, let us go with the construction part. As I told you, for every battery there are three main components. One is anode, another one is cathode, and the other one is electrolyte. So, let us see how it is constructed. Anode is nothing but negative electrode. So, it is made up of graphite electrode, which is porous in nature, upon which lithium it is doped. So, that graphite electrode, that is C6 representation, we will write like C6. So, it is to be doped with lithium. So, it is made in the form of a plate, graphite electrode. It is made in the form of a porous plate, upon which we have doped this lithium metal, purest form of lithium metal, which will play the role of negative electrode or anode. So, anode electrode is graphite, porous graphite electrode, which is having a doping of purest form of lithium. So, coming to positive electrode, that is cathode, any one of these can be used. That means lithium that is doped with cobalt oxide, that is LiCOO2, or lithium iron phosphate, LiFePO4, lithium manganese oxide, that is LiMn2O4, and then lithium nickel cobalt aluminum oxide. So, any one of these four can be used in the place of cathode electrode. So, in this case, I am going to make use of lithium that is doped with cobalt oxide, LiCOO2. So, it is playing the role of cathode, or we will call it as positive electrode. So, and then electrolyte. So, in the place of electrolyte, we are going to make use of a mixture of two components. One is organic carbonates like ethylene carbonate or diethyl carbonate, along with the lithium complex. Examples for lithium complex will include lithium hexafluorophosphate, that is LiPF6, lithium hexafluoroarsenate, that is monohydrate, and then lithium perchlorate, and then lithium tetrafluoroborate. Any one of these lithium complexes can be used for constructing the lithium-ion battery. So, cathode is nothing but lithium that is doped with cobalt oxide, and coming to electrolyte, it is a mixture of ethylene carbonate and, say for example, in this case I am going to make use of LiPF6, that is lithium hexafluorophosphate. So, once again I am explaining, anode is a porous graphite which is having a doping of purest form of lithium, that is acting like negative electrode or anode. In the place of cathode, the positive electrode, we have taken that same porous graphite electrode which is having a doping of lithium, that is doped with cobalt oxide. And then coming to electrolyte, it is a mixture of ethylene carbonate and LiPF6. So if you check the construction part, so this is the construction of lithium ion battery. As I told you, this is graphite electrode upon which we have doped lithium ion, that is purest form of lithium. And then coming to cathode, we have considered lithium that is doped with cobalt oxide. So as per our knowledge, if you notice the working reactions, anode, always at anode oxidation will take place. So that means at anode we have lithium, LiC6 is there. So by losing one electron, it is able to release Li plus, and then graphite becomes separate, electrode becomes separate. So these lithium ions along with the electrons during discharging process, they will flow from anode to cathode. So after reaching cathode, there we have lithium cobalt oxide, lithium that is doped with lithium cobalt oxide. So in this cobalt is able to gain the electron, that means it involves in reduction. So this is anode reaction, and in cathode we are having LiCO2. So it is able to accept electron. So as a result, it is able to convert into LiCO2 minus. So this LiCO2 minus is able to combine with lithium, thereby converting into Li to CO2. So at the end of the reaction, during discharging process, that means in the forward reaction, it is acting like an example for voltaic cell. That means flow of electrons will take place from anode to cathode. So because of this one, at the end we are getting Li to CO2. So along with this 3.45 or 3.75, because the range of output voltage of lithium ion battery, it is from 3.45 to 4 volts. So up to 4 volts it is able to release output voltage. So along with this, let it be like in general 3.45 volts of output voltage it is able to generate. So as that lithium and electrons, lithium ions and electrons, they migrate from anode to cathode via this separator, and there what will happen is these lithium ions, they get embedded onto this LiCO2 electrode. This is what we call as intercalation mechanism or process, that is embedding of lithium ions into LiCO2 electrode. So that's why it is an example for intercalation process or embedding process. So after this forward reaction it is completed, we will get the output voltage. As I told you, in general it is 3.45 volts. That it needs, once the charging process it is completed, it needs recharging. So for that we have to supply greater than or equal to 3.45 volts of voltage using an external source. That means using any external power source, we have to supply this amount of output voltage. Then immediately what will happen? Initially the electrode, which is acting like cathode, will act like a anode. That means it is acting like anode now. That means always at anode oxidation will take place. So as I told you, we are having this Li to CO2. At the end we are getting this Li to CO2. So this what will do is it loses electron. Li to CO2, it is able to lose one electron. Along with that Li to CO2, lithium also it is able to generate. So LiCO2 will come back. So it will come back. That means whatever be the things that were embedded during forward reaction, that is during discharging process, whatever be the lithium ions that were embedded, they will involve in de-embedding, or we can say de-intercalation. They will come back along with the electrons. Through separator they will reach anode. So now it is acting like cathode. That means reduction should take place. So that lithium is able to accept the electron by involving in reduction. Thereby it is able to convert into Li, and again it gets deposited on the graphite electrode. So this is what is happening during discharging and charging process. Let us see in detail the chemical reactions. So this is so far what I have explained. Directly I am switching to the working principle and the chemical reactions. When both the electrodes allow lithium ions to move in and out of their interiors, that electrolyte provides a conductive medium for lithium ions to move from anode to cathode or positive to negative electrodes. So, during discharging process, as I told you, it is acting like an example for voltaic cell. So, at the anode we have LiC6. So, it involves an oxidation by losing one electron and then Li plus ions will be produced. So, these lithium ions will move from anode to cathode, that is from negative to positive electrodes. This process is what we call through that separator, and this process is what we call it as intercalation, or we can say embedding. So, after reaching the cathode, there we have LiCO2, cathode electrode. This cathode electrode is able to accept the electron, in which cobalt is able to gain the electron by involving in reduction. As a result, it is able to form LiCO2 minus. So, this is having a minus charge, so it accepts lithium ion. As a result, it will convert to Li to CO2. So, if you notice the net reaction during discharging process, we have taken LiC6 along with that LiCO2 is present at cathode. They combine to form Li to CO2 plus C6, because this same terms they get cancelled on LHS and right hand side. That means lithium plus ions and electrons they get cancelled here and there. And then this LiCO2 minus and here Li to LiCO2 minus they get cancelled. So, if you add anode and cathode reactions, so these are the things that we will get finally at the end of discharging process. As I told you, Li to CO2 and C6 will be produced during the discharging process. So, if it is for the case of charging process, it allows the or it obeys the principle involved in electrolysis method, that is charging process. So, in this what we have to do, we have to supply an external power using one external power source that is greater than or equal to its output voltage, let it be like 3.45 volts. Then what will happen, again cell reactions will take place. That means initially which is acting like anode, now will convert to cathode, and cathode initially acting like cathode is now going to convert like anode. So, at cathode we have LiCO2, right? So, if you notice the previous reactions, that is during what you say discharging process, I told these two are the products. So, we have to start with these two products, because cathode initially acting like cathode, now it is converted to anode. So, these are the products at the anode now. So, at anode what will happen? Oxidation will take place. So, Li to CO2 is able to release one electron, along with that lithium will be released, because in this CO, that is cobalt, is able to lose the electrons by involving in oxidation, so that we will get LiCO2 back. That means regeneration of LiCO2 is possible after this anode reaction. If you notice the cathode reaction, that means initially which is acting like anode, that is LiC6, now it is acting like a cathode in this one. So, there we have only C6. So, from this we are getting lithium and electrons, that is from anode. So, through that separator they will reach that cathode, there they will combine to form LiC6 back. That is regeneration of LiC6 is possible after cathode reaction it is completed, that is reduction. So, if you notice the net cell reaction, that means you have to add both the anode and cathode reactions. That means on the LHS side, that is left hand side, Li to CO2 plus C6 gives rise to LiC6 plus LiCO2. That means whatever be the electrodes that we have taken or considered initially will be regenerated. So, here also like terms will be cancelled on both sides, lithium and electron, and then anything else to cancel? Let me check once. That's all. So, this is what is happening on both sides. So, as a result, LiC6 and LiCO2 will be produced. So, during this process, as de-embedding it is going to take place, this process is known as de-intercalation process, de-intercalation mechanism. What are the applications of lithium ion battery? So, lithium ion battery is having lot of applications in portable devices, as I told you, like smartphones or mobile phones, and then laptops, and then tabs, that is tablets, and then digital cameras. It is having lot of applications because of varying ranges for its output voltage. And even in electric vehicles also, as it is a very lightest metal, it is having lot of applications as a source of electrical energy. So along with that, electric cars, electric cycles, and then electric wheelchairs. So it is used as a source of electrical energy. So that's all for today's class. In this session, we discussed about lithium ion battery, which is an example for secondary battery, its construction, working, and then applications. So in the coming session, we are going to discuss about fuel cells, introduction to fuel cells, and in that methanol oxygen fuel cell. Okay, so that's all for today's class. Have a nice day. Thank you.